So we have a harmonic progression, and it is given here that the mth term of the harmonic progression has the value n times r, and the nth term has a value given by m times r. Here we need to determine the rth term. So let us begin. So first we will consider the first term. So let the first term be and the common difference of an arithmetic progression. So we're choosing an arithmetic progression first. So let the first term be denoted by a and the common difference be denoted by d respectively. Then the mth term, this is for the AP. So for the arithmetic progression, the mth term is given by a plus m minus 1 times d. And the nth term will be given by an. So that will be equals to a plus n minus 1 times d. Now here it's given there the mth term of the harmonic progression. So that's given that this is equals to n times r. And the nth term of the harmonic progression, so it's given here, its value is m times r. Now what's the mth term of the AHP? We have only found out the mth term of the AP. All we have to do is take the reciprocal. So that is going to give us the mth term of the harmonic progression. So that means 1 over the mth term of the arithmetic progression. This will be equals to n times r. So let's take the reciprocal on both sides. So we have am equals to 1 over nr. So what we can do now, we can replace the value of am with a plus m minus 1 times d. So this will be equals to 1 over nr. So let's label this as equation number 1. And the nth term of the harmonic progression, that's nothing but the reciprocal of the nth term of the arithmetic progression, an. So this is mr. So we have an equals to 1 over mr. So an is nothing but a plus n minus 1 times the common difference d. So that's equals to 1 over mr. So we're going to label this as number 2. So what we'll do, we'll solve equation 1 and equation 2 to obtain the value of a and d. So let's do one thing. Let's take 1 and from it we're going to subtract 2. So we have a and a cancelling out with each other. So with m minus 1 times d minus n minus 1 times d. So this will be equals to 1 over nr minus 1 over m times r. So we have m minus 1 minus n plus 1 times d. So this will be equals to m times r minus nr divided by m times n times r squared. So we get m minus n. So here negative 1 and positive 1 cancels out. So we have m minus n times d. This will be equals to, let's take r as the common factor, m minus n divided by m n r squared. Now clearly we can factor out m minus n from both sides and also 1r from the numerator and the denominator, and that's going to leave us with the value of d. So d comes out to be 1 over m times n times r. Okay, so we're going to label this as number 3. Now that we have the value of the common difference d, we can also find out the first term. So we can use either equation 1 or 2. Let's use equation number 1. So we have a plus m minus 1 times the common difference d. So that's nothing but 1 over m times n times r. This will be equals to 1 over n r. So we have a plus m over m n r minus 1 over m n r equals to 1 over n r. So m and 1m from the numerator and the denominator factors out. So we have a plus 1 over nr minus 1 over m n r equals to 1 over nr. So we can cancel out 1 over nr from both sides, and solving for a, we get a equals to 1 over m n r. So this is number 4. Okay, so now that we have the first term and the common difference, let's find out the rth term of the arithmetic progression. So the rth term of the arithmetic progression, so that will be given by a plus r minus 1 times the common difference d. So let's substitute the value of a with 1 over m n r plus r minus 1 multiplied to d. So d will be 1 over m n r. So that's equals to 1 over m n r plus r divided by m n r minus 1 over m n r. So we can cancel out the first term and the last term, and 1r from the numerator and the denominator factors out. That leaves with 1 over m n. So this is going to be the rth term of the arithmetic progression. However, we need not the AP but for the harmonic progression. Therefore, the rth term of the harmonic progression, that's going to be the reciprocal of the rth term, which is simply m times n. So this is going to be the rth term of the harmonic progression.